everyone. This video would focus on introduction to square roots. Let's look at this first expression that we have right here. So this expression is read as 4 squared equals 16, where 4 here is the base and this little number 2 here is the exponent. Now, how did we get to 16 here? So this 4 squared, actually, this means that we are supposed to square the 4. Squaring the 4 means we are going to multiply 4 twice. That means 4 times 4, that gets 16. Please remember that this is not 4 times 2. This 4 squared means that is 4 times 4, meaning we multiply 4 twice by itself. Now, what happens if we are given 16 and then we want the 4 back? Meaning we need to get the inverse operation of squaring a number, and that operation is square root. So from 16, we want the 4 back, which is the base. We are going to square root the 16. Now, please look at this notation that we have right here. This symbol that we have here, which looks like a division, but this is not a division symbol. This is radical sign. So this is called the radical sign, and this 16 that we have here is called the radicand. Now, there is a little number 2 right here, which is the index. For square root, the number is 2. Now, there could also be 3. So the index can also be 3, and we call that as the cube root. It can be 4. We call that as the 4th root. It can be 5. We call that as the 5th root, and so on. Now, please remember that if the index here is 2, that's a square root, it usually becomes invisible. So we can just go ahead and write square root of 16 without an index of 2. So you can see in most textbook, you do not see the number 2 there if it's square root, because again, if it's 2, it becomes invisible. But if it's 3, it has to be written in there. So pretty much to wrap it up, we define square root of a number as the inverse operation of squaring a number. Now, it doesn't work for 4 only. It works for any number. Now, let's take this next one right here. So we got a 3 squared is equal to 9. Again, this operation that we have here is squaring the number. That is 3 times 3. That's how we got the 9. Now, if we want the 3 back, we are supposed to get the square root of 9. So then this becomes square root of 9 right here. And so we got the 3 back. This also works here. If we get the base of 5, we remember again, if we say 5 squared, that is 5 times 5, and that's how we got the 25. If we want the 5 back, we are going to get the square root of 25, and that's how we get the 5 back. Please remember that these numbers that we have here, 16, 9, 25, are called perfect squares. By definition, perfect squares are numbers whose square roots are whole numbers. So as you can see, the square root of 16 is a whole number 4. The square root of 9 is a whole number 3. The square root of 25 is a whole number 5. Again, we call these as the perfect squares. Now, let's have the first 10 perfect squares. Okay, so these numbers 1, 4, 9, 16, 25, 36, 49, 64, 81 are the first 10 perfect squares. Again, this list here can go all the way to infinity. I can have 11 squared, which is 121. I can have 12 squared, 13 squared, 100 squared, all the way to infinity. So there's like a long list of numbers here, but I'm just showing you the first 10 perfect squares. Again, we remember that these ones are perfect square because if we get the square roots of this number, it's actually a whole number. If we have square root of 1, that's 1. Square root of 4, it's 2. Square root of 9, it's 3. Square root of 16 is 4. Square root of 25, it's 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. So what happens if we are given a square root of a number and it is not a perfect square? So how do we determine its value? How do we approximate its value? Suppose we have square root of 10, between which two numbers is square root of 10 located at? So I have prepared here the first 10 perfect squares and their corresponding values. So if we have here square root of 10, that is actually located between square root of 9 and square root of 16. And if we look at square root of 9, that's 3. And if we look at square root of 16 is 4. So this square root of 10 is actually located between 3 and 4. Now let's move on to the next one right here. So square root of 7. So again, we have here this list. And if we look at the list that we have here, this square root of 7 is located between square root of 4 and square root of 9. And the two whole numbers would be 2 and 3. Because again, it's located between square root of 4, the value for that is 2, and square root of 9, the value for that is 3. So square root of 7 is in between these two. Now let's move on to the next one here, square root of 70. So again, we have this list of square root and their equivalent values. So square root of 70 is located between square root of 64 and square root of 81. And that value would be 8 and 9. So I write here 8 and 9. Because then again, square root of 70 is between square root of 64 and square root of 81. Now let's move on to the next one here. Square root of 93 is located between square root of 81, which is a value of 9, and square root of 100, which has a value of 10. So it's located between 9 and 10. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!